Welcome Year 9 to the first video that's going to cover some of the similarity tests that we're going to use for similar triangles. Now we know that there are 4 of these altogether, but we'll go through these one by one. Now why do we use these similarity tests? Well, sometimes when we're given 2 triangles, we won't have all of the angles or all of the side lengths given. There might just be certain information that's given and some pieces of information missing or left off. Now, when we're working with triangles, they're a special case because we don't need all of that information to prove that 2 triangles are similar. What we can actually do is, provided we've got a little bit of information, we can use one of these tests. And that's going to prove that the 2 triangles are similar. So, we're going to use one of 4 of them, and it really depends on what information that you've been given. So yes, you have to decide which similarity test can be used to prove that the 2 triangles that you're working with are actually similar. Alright, the first one that we look at is called the AAA Test. Now, why is it called that? Well, very simply, it stands for angle, angle, angle. And what this means is that the 3 angles in the 2 different triangles, the 3 angles that that triangle have, are the same. So I don't mean that they're all the same as in 60, 60, and 60. I mean that in the corresponding angles in the 2 triangles are equal. I've written a definition for you. This is how it's written in your text. If 2 angles in one triangle are respectively equal to 2 angles in another triangle, then the 2 triangles are similar. We don't need to look at the side lengths. We don't need to check the scale factor or the similarity ratio at all. Once we know that these angles are the same, only 2 of them, you'll notice in the definition, then we know that they're similar. Now, you're probably asking, well, the definition says 2 angles, but why is the name of the test angle, angle, angle? That implies 3 angles, doesn't it? Well, we can talk about that now. Why only 2 angles? Well, if you think about a triangle, any triangle, I'll just draw one for you here. What do these 3 angles here add up to? This one plus that one plus that one. The angle sum. Oh, that didn't work quite well, did it? The angle sum is always, for a triangle, 180 degrees. Now, because of that, if I've got 2 angles, say I've got this one here, I'll put a little dot, and I've got that one there, I might put a little cross. It means that this angle here will always be 180 minus the other 2 angles that you've got. So in this case, I called it, I used a cross, minus the little dot. Now that's true for every triangle. If you've got 2 of them, then of course the third one must be the same. So if we've got 2 triangles, we don't have the third angle, we've got 2 triangles and we've got 2 angles shown, the third one must be the same. Okay, I'll show you that in another diagram actually. Here we have an example. 2 triangles are drawn here and I've got 2 angles shown as well. So what have I got? I've got theta in this triangle and I've got theta in that triangle and I've got alpha as well. Remember the little fish symbol is alpha. And I've got one here as well. That implies this angle here, CAB, is equal to angle FDE in that triangle. This angle, alpha, angle CBA, is equal to angle FED. Therefore, this angle here must be the same as that angle there. It has to be the same because these 3 angles must add up to 180. So, sometimes this test, you might see, is just called the AA test instead of the AAA. But I always write AAA. You'll see that the other tests that we do, likewise, they all have 3 letters as an abbreviation. They all use 3 letters. So I'll be consistent with that. We call it the AAA test. So what I can do with these triangles here is I can write a similarity statement. Now, you might remember from a previous video that to do that, I need to label the triangle. I'm going to call this one ABC. And remember, for similarity, you can use these 2 symbols, either this one here or that one there. I'm going to use this one. Now, I must write these in matching order, so A, B, C. If your triangle is sitting the same way, the same orientation, this makes it a lot easier. As we can see, A corresponds to D, B corresponds to E, and F corresponds to C. So therefore we have D, E, F. And what we do is we write the justification. We write, how do we know that they're similar? Because as you can see, there's no side lengths written on these triangles. Nothing is written on these triangles here. Therefore, I must say, well, I know that they're similar because of this test. This is your justification or your reasoning. So whenever a question says provide reasoning, that's basically what we're doing. In brackets, we put what test proves their congruence. Now, how do we know that it works? Well, basically, if I tried to draw any triangle with these three angles here, I could not draw a triangle that was not similar. You could try this if you want. If you, say, have a protractor, you want to set up a triangle, draw yourself a triangle, and then use the same angles to create another triangle. What you'll find is that triangle will be similar. No matter how hard you try, if you've got three angles the same, it will be similar. Okay, let's have a look at some examples. Alright, so first one, are the two triangles similar? And secondly, if they are similar, write a similarity statement. Okay, let's examine this diagram. The triangles here, they're not written the same way, or they're not sitting in the same orientation. So basically that means one of them might have been rotated around. Okay, they're not the same way up. That's one way you could say it. But it doesn't matter because we've got some angles here labelled. Can you see that? We've got alpha there, we've got another alpha here. So that means these two angles are the same. We've also got this beta symbol, and that beta symbol is the same down there. That means these two angles are the same. So how many angles do we need to be the same to know if they're similar? We only need two angles. So we've got this angle here the same, that angle there. We've got this one here, and we've got that one there. So this immediately tells us that this angle in here is the same as that one there. It has to be the same because these three angles must add up to 180 degrees. Let's write our similarity statement. Seeing as we can see that these two triangles have the same angles, we know that our reasoning, I'm going to put that in is AAA. The angle test applies for these two triangles. It proves that they are similar. Alright, now let's write the similarity statement, shall we? Now this one is a little bit different to what we've been working with so far, because as you can see, this B here is actually going to apply in both of the triangles. Okay, so I'm going to start with the little triangle on the top. I'm going to call this A, B, C. Triangle A, B, C is similar to triangle. Now, I must get this right. Have a look at the A. That's what I put first. I listed the A first. What vertex does that correspond to in the larger one? Well, it's the vertex that's next to the alpha angle. So can you see that symbol in this triangle? There it is there. What vertex corresponds to that one? It's the C. Now, I then went B, didn't I? Went A, B, C. So now I'm working with the beta angle. Which beta angle in what vertex is next to the beta angle? There it is there. It's P. And that obviously must leave B last. I wrote C last in this one. That was the unknown angle, the one not shown. And in this one here, it was the unknown or unshown one as well. So that was vertex B. This is a finished similarity statement. You've got the two triangles labelled in matching order. You've also got your similarity statement and you have your test at the end. All right, let's look at another example. Last one that we'll look at. in this particular example, it says find the values of A and B. So obviously I'm looking for, I'm just going to highlight them. I'm looking for this here, and I'm looking for this over here. Okay, first of all, I haven't been told that these are similar. So whenever you're not told, whenever it says find a pronumeral, for example, or find the value of x, and you are not told that they're similar, what you should be doing is making that similarity statement first. Okay, it's all part of your reasoning. Now let's have a look. Alpha, beta, gamma. Alpha, beta, gamma. You don't need to know the names of these, but you just need to recognize I've got beta there and there. Okay, so I've got one angle the same. I've got alpha here and I've got alpha over there, so obviously a second angle is the same. Once I've got two, that's enough, but actually we've got three that are the same. There they are. So three angles are the same, therefore I know they are similar. What we can do is quickly write a statement. Triangle ABC is similar to triangle, and let's match this up. We want alpha, then the beta, so U, S, and then T, and there it is there. Now, to be able to find these pronumerals, what I need is my scale factor, or sometimes this is called, the other word that they use, similarity ratio. To find these unknowns, I really need to know what this is. I need to know what factor has been multiplied by this triangle to get this second one here. All right. I therefore need two corresponding sides, don't I? Two corresponding sides. Okay. I can see I've got this one, where the beta and the alpha is, and I've got that one there. Those two correspond. I don't have anything else, do I? Because have a look at this one. This side here does not correspond to that one there. Look at the angles on each end. Different angles. All right. My similarity ratio is, therefore, image over the original, 40 over 16. I can simplify that, can't I? 8 goes into 40 and 8 goes into 16. So 8 goes into 40 5 times, 8 goes into 16 twice. So this is my similarity ratio. You could simplify it further, but like I said, we are going to start leaving these as improper fractions. That's okay, we can do that. Alright, what I'm going to do is find B first. B, I think, is a little easier to find because once we've got our similarity ratio, we can take one of the side lengths from here and we can whatever corresponding side length we need, and we can multiply it by the similarity ratio and multiply it by the scale factor. So if I want to find B, let's have a look. What corresponds to B in this triangle here? Well, have a look at the two angles I've got. I've color-coded them for you. I've got beta and gamma. Beta, gamma. So therefore, this side here corresponds to the B side in that triangle. Therefore, if I take this 10 here and I multiply it by the scale factor, I will get B. I'm going to do that down here. B is equal to 10 times 5 over 2. This is equal to 10 5s are 50 over 2. 50 over 2 is 25. 50 divided by 2, that's what that is. So therefore B is 25. There we go. Now the unit's already there. So the B itself is 25 because centimetres is already shown in the diagram. Okay, finally, let's find A now. A is a little bit different because A is in the smaller triangle, not in the larger one. So what corresponds here? Well, obviously it's going to be this side here, isn't it? The 22.5 centimetres corresponds to the A. So what I can say is A multiplied by the scale factor would give me 22.5. So I might just write that now. A multiplied by the scale factor would give me 22.5. So in that case, I've worked it out similarly to B, but this time I can't do the multiplication yet. I'm going to have to rearrange. Oh, and I've run out of space somewhat, but that's okay. Therefore, if this is being multiplied by 5 over 2, what I can do is say A would be equal to 22.5 divided by 5 over 2. That's equal to 22.5 times 2 over 5. So what I've done there is the little keep, change, flip rule. If you are dividing by a fraction here, change this to times or to multiply and flip that fraction. So 22.5 times 2, what's that equal to? 45 over 5. This is 9. So A is therefore 9. Now, no, this is a little tricky once you start getting these decimal points. This one actually worked out quite well because we multiplied it by 2, so therefore we had a whole number. So actually it was quite a good question in the end. This one here, some of you may not work it out that way. Some of you might just do it this way here. Noticing that to go backwards, if you're going from the larger triangle to the smaller one, you would divide by the scale factor instead of multiplying. So that's okay as well. You can do it that way. Okay, thank you very much for listening, ladies. We'll finish it off there. It has been a bit of a longer video. I wasn't expecting it to be this long, but that's basically just the AAA test, and that's a possible question that you can come across, that last one there, where you need to find a pronumeral. Now, like I said, I've said all the way along, pause where you need to jot down these examples for your notes. Thanks very much for following along with this video.